I guess here are your notes 4c.5. These are going to be the last notes for the trigonometry unit of 4c. We're talking about angle of elevation, angle of depression. Okay, I know some of my students have heard me already use these terms. When you fold this foldable, the first thing I want you to do is make sure that when you fold downward, you're going just above that black line. When you fold the bottom up, make sure you're folding just below it so that you can actually see that black solid line between the two, okay, because we're going to be naming that. And speaking of which, what we are going to be naming that is that black line right there is going to be what's called your horizontal. It is a horizontal because it's horizontal. And this is we're going to bring this horizontal back in a little bit. So this dashed line right here, if we're actually standing right here, this is where we're going to be, this is going to be basically our reference angle from both directions. This dashed line right here is going to be what we call our line of sight. Don't know how to spell, do I? Light of sight. This will be our line of sight. Meaning, if we're standing here and we're looking upward, that word upward helps us realize that we are going to be, our head is going to be elevated, our vision is elevated. So here, from the horizontal, going upward to the line of sight, we're going to wind up with our angle of elevation. Okay, and that's what we're filling in here too. So going up, to elevate is to go up, like elevator, I know elevators go up and down, but elevate is to go up. So if we're standing here and we decide to look upward, we're looking at the angle of elevation from the horizontal. So just from the horizontal here up, this will be our angle of elevation. Okay? The other side is going to be looking downward. So if we ignore this part, now we're looking at the horizontal, and let's say we're up in the air and we look downward, okay? Still looking at, this is going to be our line of sight again. I think I'm spelling sight wrong all over them. I'm spelling everything wrong. All right, line of sight, this kind of sight, you're seeing sight. All right, so you're going to be looking downward, and this is the direction you're looking. Okay, so we're going to be looking down, and this is called your angle of depression. Depression is known to be, if somebody is depressed or feeling depressed, they're feeling down. So that's the way to remember that. So this way here, we're looking at the angle of depression. All right, we'll look at examples of both of these. When we open up the top part and talk about our angle of elevation here, okay, we're going to label some things again. And down here we have our horizontal. So this is like the ground, okay? And our definition here is stating that an angle formed by a horizontal line right here, and the line of sight right here, we'll write again, line of sight, hopefully I'll spell everything correctly this time, and our line of sight to any point on that line. So we're over here, we're forming an angle with this horizontal line going upward at any point over here, okay? The line of sight, the angle of elevation is going to be a point above this line of sight. Okay, so an angle formed by a horizontal line and a line of sight to a point somewhere above this horizontal line. Okay, so again here we have, just repeating what we have on the outside, our angle of elevation. So our example up here, my black marker, our example up here is a hiker is standing 220 feet from the base of a cliff. The angle of elevation from where he is standing to the top of the cliff is 29 degrees. How tall is the cliff? So again, we have word problems. We need to start by drawing a picture. So we have a guy over here, okay? He's smiling, he's all happy. And we have a cliff that's way over here, all right? He is standing 220 feet from the base of the cliff. So he's standing 220 feet from here. So this right here is going to be our 220 feet. And we should know by now this cliff, we should maybe see this cliff and this ground, that's where our 90-degree angle is going to be created. Okay, so the angle of elevation from where he is standing from here to the top of the cliff is 29 degrees. So from here, elevation will go up. Okay, so that's looking at right here, this angle of elevation, we're going upward, is going to be 29 degrees. The question that they are asking here is, how tall is the cliff? So we're looking at how tall over here. All right? So we will start off by labeling our reference angle, which is kind of already labeled for us right here, right, with our arrow. So we can consider that our labeling our reference angle. Then we're going to label our sides. We know that across from the 90-degree angle is a hypotenuse. We don't have anything there, so we're not going to mark anything. We're standing at the angle. If we go to the opposite side, we're going to have our O for opposite. And then down here, the ground is going to be our A for adjacent. We notice the O and the A, and we notice that O and A is going to be involved with tangent. Okay, so our equation that we're going to write, which we should be really good at now, understanding, the equation starts with our function, which is going to be tangent, so tan, followed by our reference angle, 29, is equal to the ratio of our opposite over our adjacent, so we have the opposite x over our adjacent of 220. Go through this pretty quickly because we've been doing this for quite some time now. Multiply both sides by that 220, so these cancel. And then we can come up with, once we put this into our calculator, as 220 times the tangent of 29. We will find out. Go ahead and pause it and put that into your calculator on your own. Now, it does not tell us what to round to, so we'll just round to the nearest tenth. It should come out to approximately 121.9 feet. That is how tall this cliff will be. Okay, so the only thing that's changed here is the words angle of elevation, angle of depression. You just need to know angle of elevation is going upward to your hypotenuse from the horizontal line, and angle of depression will go downward. Let's look at that example. Okay, so we still have here our horizontal. I guess I can just leave this all open. We have here our horizontal line, okay, and then here now we're standing here and we're saying that the definition of, look at what color I use, green. The definition of the angle of depression is an angle formed by a horizontal line, and the line of sight right here, we have our line of sight, it's going to be an angle right here formed by the horizontal and the line of sight to a point. Now we're going below the line. So we're looking at below. Now when it says the line, what they're talking about is your horizontal line. Okay? So from this horizontal line, any point below it, this becomes our angle of depression. All right? So when we take a look at the example we have here, down below, we actually have a picture drawn for us. There's something that we are going to have to realize here. When we are, a lot of times when we're dealing with the angle of depression, we are standing up top somewhere and we're looking downward. So we have a forest ranger, okay, and he is on an observation tower up here, and he's going to see a fire. The angle of depression to the fire is 7 degrees. So what we're looking at, the angle of depression, is right here. This is your angle of depression going downward from the fire. So what we also need to notice here, so that we can actually solve this triangle right here down below, because all we're really focusing on here is the tower, okay? It's going to be away from a fire. I'll draw my awesome little fire. We need to figure out, our triangle is going to be actually here. Here's your 90-degree angle. But we notice the angle is up here. So we need to notice here that we do have parallel lines. And that brings back in this diagonal, the hypotenuse, is going to wind up being the transversal. Okay? So when we're talking about this angle of depression, but we're looking at this section, we need to look at either this angle up here or this angle down here. And what's going to end up happening, we're going to note down here that your angle of elevation and angle of depression have the same measurement. And the reason for this is because of these parallel lines. So because we have these parallel lines, we end up with alternate interior angles. Okay? So that's going to be this angle right here and this angle right here. They will be congruent. So here we have the angle of depression going from a horizontal, like right here, downward. Okay, but we're focusing on the triangle down here. So what we need to notice is this angle of depression is going to be congruent and the same as this angle of elevation. So if you're going from this side, you're looking down. If you're going from this side, you're looking up. They will be congruent, which is going to make this angle 7 degrees as well. So we just take out this triangle. We're going to notice down here by the fire, this will be 7 degrees. Okay? We want to know what is the horizontal distance. Oh, sorry, we forgot here. We have a forest ranger on a 90-foot tower, so we need to make sure over here we're labeling this as our 90 feet tall. We want to know the horizontal distance. So that's going to be a big thing. The horizontal distance between the tower and the fire. So that's going to be this side right here is going to be your X. Okay, that's what we're looking for. So with all that in mind, now we can go through and we can say, okay, let's look at what we have. Here we have our reference angle, right? Reference angle is 7 degrees. That's step 1. Step 2 is labeling our sides. We notice across the 90 we don't have an H, but all the way on the opposite side of the angle we have O, and right next to the angle we have A. So we have opposite and adjacent, which is going to bring back our tangent of opposite over adjacent. Most angle of elevation and depression problems are going to be tangent, but not all. Okay, not all of them will be. So focus on those A's, O's, and H's. So here we'll write out our equation. We're going to have the tangent of our degree measurement 7 is equal to opposite of 90 over adjacent of X. At this point, what I'm going to do is I'm going to do the switch and divide way, where we take the tangent of 7 and take the X, and they're going to switch places. Okay? So that 90 is going to stay on top, but X is going to move over here where the tangent of 7 is, and the tangent of 7 is going to come over here where the X is. So that is your switch and divide. So pause, and all you need to do is divide 90 by the tangent of 7 and round to the nearest. I think this one comes out to a whole number. Okay, so go ahead and plug that in and then resume to get your correct answer. Now that you have done it on your own, we should have found that x is going to come out to 733 feet. Okay, so there's your angle of elevation, starting horizontally going up, and your angle of depression horizontally and going down. And here we can see if we have the two horizontals going, if you're standing on the tower looking down at the fire, that angle will be the same as if you're in the fire looking up at the tower yelling for help. And that's why these two angles will end up being congruent. All right?